All right, so let's get into what we're getting ready to look at for the next few days here, the kidney. It's a very important organ. It's good we came from cardiovascular because, and pulmonary, because we have a great understanding of capillary now. And that's basically all it's about. The kidney's about a capillary, but a specialized capillary. It's a specialized capillary. We already understand then that if I were to, but before we get into that, here are our kidneys, right? We've had probably some people have eaten kidney beans, so we get the shape, right? There's a concavity portion to the kidney, and then there's what? A concave, right? And so what we're going to have in the middle is a very important group of capillaries, very important group of capillaries. And we're going to look at another feature related to capillary than what we've already dealt with. At capillary level, at tissue level, we've always dealt with the fact that that's where now oxygen's getting dumped off, right? And where carbon dioxide comes in, right? So it's the exchange, that feature of knowing that capillary is going to give tissue something. But we're going to kind of shift it and look at the fact that there are those pressures we talked about. We talked about hydrostatic pressure, did we not, maybe? Yes, hydrostatic pressure was at the arterial end. And then we had, what was the other pressure? Osmotic pressure at the venous end. And that's a big feature of the kidney, right? Because now we're going to switch our look of not just giving off some oxygen and nutrients, but creating a pressure so that now we're having a process of filtering. Yes, filtering does occur. We didn't talk about it, but at tissue level, what's happening is that at the arterial end of a capillary, you have some things that come out, but does everything come out? Yeah, some things, especially big things, large proteins, blood cells, right? So not everything comes out, right? And so if you put if you put some sort of apparatus on your faucet in the kitchen, right? And it only allows certain things to come through, like water, but other things like impurities can't. What's happening there? That's called what? Filtering. And that's your kidney. Your kidney's filtering what? Blood. What's in the actual blood vessel? What's in the capillary? Blood. So your kidneys are filtering blood using that pressure. Yes, that pressure is actually pushing the fluid out. And that's what's special about the kidney. So what I want you to imagine is this. This is the kidney, right? You have two of them, okay? You have your right kidney and your what? Left kidney. And inside there, what you have is, and I like to give the example of a wet towel, right? Wet towel representing your actual capillaries. And what does that wet towel have? In plenty of fluid. And so what are you going to do? You're going to wring it out. Wring out the towel. That's all the kidney's doing. That actual capillary system it has is just capillaries getting wrung out, right? And what's going to come out of it is fluid. Okay, fluid that your body no longer wants. That's the whole object, right? But let's look at that feature. If I wring out the towel, and what do I have underneath of it? A bucket, right? And so now, what I'm going to do is wring the towel, water falls in the bucket, but what's in that actual towel? Who can tell me what's in that towel? What did I wring out? I wrung out things that, and let's say that was blood. What did I wring out? Because it's kind of a gross way of wringing everything out, right? Like, what did I wring out? Yeah. Huh? Plasma. There you go. Okay, plasma. And what's in that plasma? Water. That's the main thing right there, right? She said solutes, like names. She's right. What's solutes? Sodium, potassium. Those things we've been talking about that are very important related to what? Generating an action potential, right? So do we need those things? Yes. Nutrients. What did I wring out? I wrung out glucose. Yeah, that's in the bucket. And let me tell you something. That bucket is getting ready to go out. This is what I'm getting ready to do with that bucket. I'm going to take it and dump it out. Dump it outside. Is that good? No, because that was where? In your body, right? So what's our concern with the kidney? When it's doing that, oh my goodness, you get ready to throw out water, glucose, sodium, potassium, right? So the other part of the kidney is to after. Well, why did he bring it out? Why did I put that in the bucket? Because what else is in that plasma? What else is in? Okay, well, really not so much, right? Because did the proteins come out? Proteins really didn't come out, did it? See, that's the filtering process. Especially which protein stayed in there? Albumin, right? So what we don't want to see in that bucket at all, what shouldn't be in that bucket, is things that shouldn't be filtered, which is protein, right? So are there going to be those small parts of a protein? Yes. What's the building blocks of a protein? Amino acids. So because they're smaller, some of that comes out, right? But we can't say proteins, right? In fact, that would be bad if proteins ended up in that bucket, right? We'll come back to that because when we check the kidney function, that's something we shouldn't see, should we? In your what? So when I'm saying that the buckets get thrown out, what is that actually? That's what you do every day. What is that? Yes, urinate. So what you're gonna have is you're wringing out these capillary, then they're gonna end up outside the body, right? And so that bucket represents something in that kidney that we're getting ready to get to. It's called a nephron. Okay. So nephron is very important because it's already outside your body. It's a tube system. It's a tube that collects what's been filtered, right? So all that's been filtered is good stuff, right? But also what things? Bad things. Okay, that's the whole purpose of the kidney. He really wants to actually get rid of that. The reason why the towel was run out was so that you could get all the bad things in the bucket. Problem is that what did you end up doing? Initially, you ended up letting what? Things that you like in that bucket. So you put what in that bucket? Water, sodium, potassium. But what else is in that bucket? Things you don't want. And this is to see, when we talk about with pulmonary, that main waste product that we make, we took care of that. Okay, so he's not involved with the kidney because how did we get rid of that main product? We breathe it out. What was that main waste product? Pulmonary. We took care of that with pulmonary. But you have other waste that cause major, major problems. You have a lot of other waste. For instance, this guy right here, that actually Anu brought up. And who is this? That's an amino acid. And when you put a whole bunch of those together, you get a protein, right? Now, what typically happens in your body is that your proteins are recycled all the time. So they're always chopped up here and there and reused. And sometimes they're not going to be put back together, and the byproduct from them getting chopped up is this guy here. You see that? What's that? An N and two H's, right? But if you just add one more H, what is that? So this is created in your body so many times. And is ammonia good for you? No. When we looked at that pH scale, that would make the pH really high. Is that good? No. You want neutral. High is just as bad as low. Low, you put low on your skin, you burn your skin. You put high pH on your skin, burn. That's called caustic. That's a caustic fluid. Just like Drano. If anybody has Drano in their house, bleach, you put that on your skin, you see it starts to tingle, right? It's bad for your skin. So yes, this is a harmful product, constantly made, and now we're relying on our kidney to get rid of it, right? Because that's when I actually wrung that towel out, and all that fluid ended up in there. He ended up in there, all right? So we wanted to get him out of your body, all right? And now eventually, what's going to happen? That bucket's got to be what? Taken out. That's your urine. So this is the whole thing that we're going to be looking at is this feature. That bucket, it has so much good stuff in it, we're going to have to get it back. But we're going to leave the what? We're going to leave the ammonia and things that we don't want in the bucket. You understand? So what are you gonna have? This is what I want you to visualize. I run the towel out. Very important concept of the kidney. Okay, that's at the glomerulus. I'm gonna come back to it. That's the glomerulus, right? We filtered out blood. Blood ended up in the actual what? Bucket that's getting ready to go out of your body. That's the nephron, right? I'm still in the nephron, but what's that nephron like there? Take out water. I need the water, right? It's gonna take out sodium. I need the sodium, right? It's gonna take out what? Potassium. It's gonna take out very important things I need, right? Glucose. It's gonna take that out. Amino acids. And guess what? As soon as it gets to that window, what's gonna happen? Now I'm gonna dump it out. You see? So what did I do? That nephron was very important for me to do what? Save the things that I need. Okay, and then by the time I'm getting ready to get that what bucket thrown out, the waste are in there. Your ammonia is in there. Okay? Another product that ammonia turns into, because see, ammonia is so bad, your liver takes it and he makes it into a more or less toxic substance called urea. Okay. All right, so your ammonia, by the time I'm getting ready to throw out the bucket, you've got plenty of what? You got your ammonia and urea in the bucket. Now that gets thrown out. In your urine, that's what you have a lot of. Right? You got ammonia, urea. Okay? All right, and so that's the whole purpose. That's what we're ready to talk about. That whole important feature of that. You see how important that is? Though? Let's say that your kidney is dysfunctional. Let's say that nephron I'm talking about. That whole nephron that's bringing back water, sodium, and all these good things, glucose. What if something's wrong with that nephron? You gonna get back your water? You see? What happens with your blood volume? See? That affects everything, man. Now you're getting ready to die. You see? What about glucose? Its nephron is messed up. Can you get the glucose back? Now you're what? You don't have glucose. It doesn't go in the cells. You don't get what? Energy. You die. You see, kidney's huge. Very important. If there's the dysfunctional kidney, we got big problem. Okay. So yes, that's a very scary concept there. That what's happening is that all the good things in your body in the kidney are actually getting ready to go out of your body. So you got to make sure your kidney's totally functional. So that's why we have to order blood tests. And we're always checking that blood, but we're always checking to see if kidney is functioning okay. So that means I'm checking levels of what? Sodium. I'm checking your levels of what? Potassium. Your amount of glucose. Yes, when I'm checking those levels, I'm checking who's function. Kidney's function. We call it the kidney function. Basically, when I'm checking out all of those what? Electrolytes and all of those different molecules that we vary. So let's peek at what I'm that first thing. That first process, me wringing out the towel, right? So if I'm wringing out the towel, we're right here. See that right there? What's that word there? Does that look familiar? It says arterial. You remember arterial? What cardiovascular? Arterial was right before the what? The capillary. See that? Same thing. So we have an arterial in the actual what? Kidney, and then you have your what? Okay? We call it the capillary bed. It's the weirdest type of capillary scenario though. Because typically with a capillary, you can see those different colors here. Right. So when we look at, here's my arterial, and then I'm going to have my what? Capillary. Okay? Weird thing though is that And this is what you usually have.